Yes, so we are number 13, and it reads, Shana selected one fruit at random from a box containing 16 mangoes, M for mangoes, and 14 apples. She ate it, then randomly selected another. Construct a well-labeled diagram to analyze all the possible outcomes with their corresponding probabilities. For those of us that have looked at the video I sent with for number 12, you will see that I have reminded you all that mathematics is very important, because what it does, one of the main things it does is convert a real life scenario, a real life phenomenon, into a concept, into equations, and also a diagram. So you see this is two sentences. Those two sentences there, imagine those two sentences you see there, Shana and apples, full stop, she and another, full stop. This information can be represented on a diagram. Okay? This information there, you see all of that words, those two sentences can be displayed on a diagram. Okay? And in probabilities, it's called a tree diagram. Okay? The tree diagram we're going to use for this course, as I told you all already, that it will be a 2x2. Okay? And here the template for it. 2x2. 2x2 meaning two sections, and each section will have two possible events, two events. So section 1, you have two events. Each event is represented by a branch. The node will detect, will partition from one section to the next. Okay? Each node will have two events branching out from it. So that's why I call it a 2x2. And if you look at the example, all right, if you look at the example, you will see that there are two sentences. All right, if you have to compare it to number 12, the two sections is Wednesday and Thursday. That will be time, when the event is happening. But the section also depicts all right, when and where. Okay. That first sentence is the information for the first section. The second sentence is the information for the second section. Okay. Our sections here will be labeled as selection. So the first section here will be the first selection, because she's going to select. All right. She's going to select a first selection. All right, let's go to the assignment question. Right, that's the assignment question. First selection and then second selection. Okay. So the example we're going to use now is Bill, and you have first selection and second selection. Here he'll be selecting cards. Okay, so let us capture this. Just a minute. Let's make somebody join. Right. Here, so first selection, second selection. Okay. Now the event will be what is happening in the first selection. What is the verb? what is going on, what is occurring. That will be the event. He will be selecting one card at random from a box containing 10 green and 5 brown. 10 green cards and 5 brown cards. And just to remind you all, the tree diagram, what it does is display all the possibilities, all what that can happen. All right, that's what it does. It's a diagram that will display all the possibilities. So when he randomly dips his hand in the container, what can possibly happen? All right, what can possibly happen? It is possible for him to select a green or a brown. Okay, imagine you close your eyes and you're going to dip your hand in the container. Okay, beforehand, because you cannot predict the future. Beforehand, you don't know what color card you're going to select. And listen to the words. You can either take a green or a brown. And we know what or signifies in probabilities. Or signifies that you have to plus. Okay, so these are the two possibilities. And probabilities now will measure the possibilities. So it is probable that he will take a green or a brown. Okay. Right. So I just get an idea right there. So think about that. It is probably, there's a probability that he will take a green or he will take a brown. Okay. There's a probability that he will take a green or he will take a brown. So you can see what I'm doing. So I'm using, you know, the opportunity to do that. And it's by coincidence, I color coded this in green. So there's a probability that he can select a green, right? Remember the branch representing what can happen. So there's a probability to get a green. In the first selection, remember he's going to select, dip his hand for the first time. So in his first selection, he may get a green or he may get a brown. Okay, so probability of green or probability of brown. So you see what is happening? This first sentence, another experiment is such that Bill will be selected one card at random from a box containing 10 green cards and 5 brown cards. Okay, that sentence there, look, it is now being transformed into a diagram. In Bill's first selection, he may choose a green or he may choose a brown. Okay, it's the same information represented as a diagram. Now, what is the probability of him getting a green? So in this scenario, unlike for number 12, you are given whole numbers. You are given 10 and 5. You are not given 0 points. If you compare this to number 12, you are not given 0 points. You see, like number 12 is the probability of him coming to work late. You have 0 point and 0 point. But what you are going to do now is to use this formula, the fundamental formula for probabilities. This is what we are going to use to calculate the probability of him getting a green or brown. So we're going to use this formula, frequency over total frequency, to calculate what is the probability of him getting a green. So in his first selection, there are 10 green cards. So the frequency of green is 10 and the total frequency is 15. I repeat, here we are not given the 0 point. We are given the quantity, frequency of green, frequency of brown, 10 and 5. So there are 10 out of the 15. 10 out of the 15. So that is the probability of him selecting a green in his first selection. 10 out of 15. The probability of him selecting a brown, there are 5 brown out of the 15, 5 out of 15. The probability of him selecting a brown is 5 out of 15. Okay, and if you want to verify, remember, is a green or a brown, or means we have to add. So 10 over 15 plus 5 over 15 should give us 15 over 15, because we said that the fundamental rule again for the tree diagram, across each node, when you add the probabilities, it must add up to exactly 1. So this first sentence, Bill will be selecting 1 card at random from a box containing 10 green cards and 5 brown cards. This sentence there, here it is in the form of a diagram. In his first selection, the probability of him getting a green is 10 over 15, and the probability of him getting a brown is 5 over 15 in his first selection.